Okay, hello again. Now, today we are going to be talking about series parallel circuit. First we talked about the series circuit, then we talked about the parallel circuit. Today we're going to combine them and talk about the series parallel, and we're going to see how voltage and current is distributed in a series parallel circuit. So let's go ahead quickly and draw our circuit. Once again, we have our source, which is 10 volts. We have R1, we have R2, we have R3. R3, 4 ohms, R2 is 2 ohms, and R1 is 3 ohms. Now, I need to say something about the series parallel circuit because many people have difficulty even interpreting whether a circuit is a series circuit, a parallel circuit, or a series parallel circuit. If you're having that difficulty, a little trick you could use. Start on one side of the battery and begin to walk along the lines of the circuit. As we travel through this resistor, how many parts does the current have to travel? Only one, right? So far it's a series circuit. We continue traveling, and when we get to this node, something happens. The current now has a choice to travel this way or to travel this way. So we have met a parallel combination. Before it was just series because there was only one path for the current to pass. Now the current has a choice of 2 paths to pass. Therefore it's a parallel combination we have come to. So the current will travel, some will come this way and some will come this way, and then they will come back together at this node and return to the battery. Thus we know it's a series parallel circuit. Continuing with our series parallel circuit, we are going to find the total resistance for this series parallel circuit. To start with, we're going to find the parallel combination of these 2 resistors. And it's simply going to be Rp, sorry about the noise, is equal to R2 times R3 over R2 plus R3, which is going to be 2 ohms times 4 ohms over 2 ohms plus 4 ohms. And if you were to work this out, you're going to be getting a total of 1.33 ohms. This is your Rp combination. It is not the RT, because we have not yet taken into account R1. Knowing this, I could redraw my circuit, okay? And if we were to look at this, what kind of circuit is this? That's right, it's a series circuit. Or we know how to find total resistance in a series circuit. It's simply going to be R1 plus Rp. And if we were to add them up, it's going to give us a total of 4.33 ohms. This value is the total resistance for this whole series parallel circuit. So let me just quickly put this in here, 4.33 ohms, which is our RT. I will remove this, no longer need it. Now, other things I could find with this circuit. How much is the total current that flows through the whole circuit? Well, it's simply going to be IT is equal to VT over RT. That's going to be 10 volts over 4.33 ohms, which gives us a total of 2.31 amps. So that's how much current that leaves the battery, flows through the circuit, and returns to the battery. 2.31 amps. So I'll just quickly put this here. IT is equal to 2.31 amps. All right, let's remove this. We no longer need it. Let's go ahead now and find how much current is going through R2, how much current is going through R3, and also how much current is going through R1. Now IR1 is going to be equal to IT, because remember up till this point, this resistor is in series, and we know that current is the same. So the same amount of current that leaves the battery, all of it will travel through the series resistor. So this is going to be equal to 2.31 amps. However, IR2 and IR3 will be different, because we learned that in a parallel circuit, current is different across each component. So IR2 is going to be equal to VRP over R2. Please note, I did not put VT there. I put VRP. So whatever voltage is found across this node is going to be the same voltage across this node. It's not going to be 10 volts. I'm going to show you that in a second. So this is going to be equal to 3.07 over 2 ohms, which gives us a total of 1.53 amps. Okay? So let's put that in, 1.53. Now, IR3, same thing again, VRP over R3. That's going to be equal to 3.07 all over 4 ohms. 3.07 volts. If we were to put that in our calculators, we get a total of 0.767 amps. And like I said before, if you wanted to double check this, if you were to add up these two, which you will do, and let me come to class and let me know, and see if you get back IT. Okay? Now VRP, which is the voltage across here, is going to be equal to IT, okay? Remember, this is our series circuit. So whatever voltage drop is across here will be across here also. So it will be IT, because IT will flow through all of this, the entire circuit. Remember that what IT is. It will be IT, let's just see, okay, it will be IT times RP. That's going to be 2.31 amps multiplied by RP is 1.33 ohms. And that gives us, if we were to put it in our calculators real quick, a voltage of 3.07 volts. So the voltage at this point is not 10 volts. If it was a parallel circuit, it would have been 10 volts. But because it's a series parallel circuit, the drop here is 3.07 volts. And of course, whatever is here is going to be here also. Okay? And it's as simple as that. If you have any questions, next time we meet, you could bring them up with me. Thank you, and remember, study hard.